Hello and welcome. Let us continue our discussion on types of relations. So the last type of relation is transitive relations. Let's discuss this type of relations in this video. So the definition for transitive relation is a relation a relation R is said to be is said to be transitive is said to be transitive if if all A comma B comma C and A comma C, all these elements are are the members of R. All of these, if all of these belongs to R, then we can say the relation R is symmetric. Let us consider an example to understand this better. Let us say we have set A as 1, 2, 3, and let me define R as 1 comma 2, 2 comma 3, and 1 comma 3. So here this relation is transitive. This relation is transitive because, so if you consider this as A and this is B, so A comma B is a member of R, and this B, so 2 is B now, so B is paired with another element C, so B comma C is also an element of R. So if both of these are present, then we have to check whether A and C are also present in R. So here we can see A is 1, C is 3, so A comma C is also the member of R. In such case, the relation is transitive. Let's take one more example. Let's say if I have R is equal to 1 comma 2 and 2 comma 3. So here this case it is not transitive. It is not transitive. Reason being, so A comma B, A is 1, B is 2. A comma B is a member of R, and also B comma C is a member of R, but we don't have A comma C. A comma C is not a member of R. So here, so it's not transitive. There are some hidden cases this as well, as we saw in symmetric relations. So let us write some notes on this. The note is the first case, if A comma B is a member of R and B comma C is also a member of R, then check for the presence of A comma C. So if A comma C is present in R, then it is transitive. This is pretty straightforward. If 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 A comma B is a member of R, B comma C is also a member of R, and if A comma C is not there in the R, is not in R, then this is not transitive, and this is not transitive. The third case is important. If A comma B is a member of R, but B comma C is not a member of R, then we need not to check whether A comma C is there or not. So if only A comma B we don't have B comma C, then we need not to check for the presence of A comma C. In such case it is transitive. To understand this, we'll solve some problems. Let's take one problem. let's say we have r equals 1 1 comma 1 comma 2 comma 2 and 2 comma 1 and 1 comma 1. So what we can do here is, let us take, this is A, this is my B, this is B, and this is C, this is A, and this is C. So what we do is, first we take the first element A comma B, and we'll see any of the elements starts with B. So here we already have 2 comma 1, so we have an element which starts with B. So here A comma B, which is 1 comma 2, is a member of R. So we'll check whether any element starts with B, that is 2. So B comma C, so we have an element called 2 comma 1. So now this also belongs to R. So both A comma B and B comma C are belonging to R. We need to check whether we have A comma C in the relation R. So A comma C is, A is 1, C is also 1. You can clearly see 1 comma 1 is there in R. So this is actually symmetric. This is transitive. One more example we'll solve. We have R is equal to, let's say we have only 1 comma 2. Now we have only 1 comma 2. So this is my A comma B. A comma B, A is 1 comma 2. E is a member of R. What is B comma C? B comma C is 2 comma any number. So we don't have that in the relation R. Since B comma C itself is not there, we need not to check whether A comma C is there or not. So here we can stop our search, and we can directly say it is transitive. It's transitive because B comma C is not there. Like this, we can solve one more problem. Let us take R equals 1 comma 1. Again here also taking the same set, A is 1, 2 and 3. In the previous video we discussed, in set we write every element only once. So it means even though the elements are repeated, we are writing it only once. So if any element is been written once, we can write it as many times we want. So this I can also write as 1 comma 1, 1 comma 1, 1 comma 1, because I can take these three elements to show it is transitive. I'll take this as A, this is B, this is B, this is C, this is A and C. So here A comma B is a member of R, B comma C is also a member of R, A comma C, A comma C, A comma C is also a member of R. So in this case, R is transitive. So whenever we have repeated numbers, so it is actually self-transitive, and we saw the similar thing in symmetric properties or symmetric relation also. So in this case, if it is repeated, it is transitive. We'll take one good example. We have R equals 1, 1, 2, 2, 3, 3 and 1, 2. We need to check for A is same, A is 1, 2, 3. We need to check whether this is transitive or not, whether it is transitive or not. So what we do is we take every element. So I'll take 1 comma 1. So this is my A and this is my B. So A comma B is a member of R. Then I'll search any element. I'll search for any element that starts with B, which is 1. So we have one element which starts with 1. So this I can write as 1 comma 2. So this is my B, this is my C. So this means A comma B is a member of R, B comma C is also a member of R, here which is 1 comma 1 is a member of R, 1 comma 2 is a member of R. So I need to check whether A comma C is a member of R or not. So A comma C is A comma C is A comma C is actually 1 comma 2 itself. So this is also a member of R. We can say this is a member of R. So 1 1 and 1 2 can be treated for transitive case. Next we'll go for the second case. Second case is we have 2 comma 2. So this is A comma B. What I do is I'll check for element which starts with 2. So there are no elements which starts with 2. So even though A comma belongs to R, B comma C does not belong to R. So this is also helps us to uh, tell this relation as transitive. Next we'll take case 3, which is 3 comma 3, and A comma B is a member of R. I'll check for any other element that starts with 3. There are no elements in R that starts with 3. So I can conclude B comma C is not a member of R. So this also contributes for transitive. So all these cases are true. So the whole relation is transitive. Whole relation is transitive. So if any of these cases fails to prove transitive, then we cannot say the relation is transitive. So one counter example is good enough to disprove or to say a relation is not transitive. We can take one such example, uh, like let's say we have R is equal to, 1 1 1 1 and 1 1 2 1, and let's say we have 3 2 1 1 2 1 and 3 2. It is transitive. let's take we have 2 comma 1. Okay, we'll see this only. This is good enough. We'll start with 1 1. So this is AB. AB is a member of R. We'll see whether any element starts with B. So here, other than this, no element starts with 1. So B comma C is not a member of R. So this condition we can take it as S. Second, we'll take 2 comma 1. 2 comma 1 is my A comma B. 2 comma 1. So we have to check whether any element starts with 1. So we have one element which is 1 1. So this is my BC. So here AB belongs to R. BC also belongs to R. Does AC belongs to R? What is AC? So here it is, AB is 2 comma 1, BC is 1 comma 1, and AC is this one, 2 comma 1, 2 comma 1. This also belongs to R. We have 2 1 already we have. So this 2 1 serves both as A comma B and A comma C. So this is also giving me S. Option 3 we have 3 comma 2. 3 comma 2 is my AB. Does any element start with 2? Yes, we have this one. So we have 2 comma 1, which is B comma C. So we have A comma B belonging to R, which is 3 comma 2 belonging to R. B comma C is also a member of R. B is 2, C is 1 belong. So now we need to check whether A comma C is a member of R or not. What is A? A is 3, C is 1. So 3 comma 1 is not a member of R. So this will not give you S. So this one example, one itself is enough for us to say this R is not transitive. R is not transitive. So one counterexample is enough. That's what I wanted to say. Finally, we'll end this video by one note. So if if a comma b is not, if a comma b belongs to R, b comma c does not belongs to R, then R is transitive. We know this. Similarly, if I have an empty relation, I don't have both a comma b and b comma c. A comma b is also not there. B comma c is also not there. In such cases also, we can say it is transitive. So all empty relations is transitive, and all universal relations is also transitive. So I encourage you to check why it is. So we'll summarize what we discussed. So if I have an empty relation and I have universal relation, empty relation is not reflexive, because if we want to say any relation reflexive, all the elements, every element of set A or any set should be related to itself. So in empty relation we don't have any relation, hence in empty relation we don't have any elements, so it's not reflexive. And empty relation is symmetric. All empty relation is symmetric because of the hidden case. All empty relations are transitive. Here universal relation is reflexive, symmetric, and transitive. So with the help of these discussions, we can move on to solve some problems on types of relations that we'll see in the next videos.